Good day, everyone. My name is Khairina Binti Khairul Zulkarnain, and today I'll be presenting my network project for the course MTAS 3323 Discrete Mathematics. In this project, I explored how graph theory can be applied to real life delivery systems. Graph theory provides a structured mathematical way to analyze systems involving direction and distance. For example, transportation routes, courier networks, and communication links. In this study, I used a directed weighted graph or digraph where every route has a direction and a cost, such as distance in kilometers. To find this most efficient route, I applied Dijkstra's algorithm, which is one of the most reliable shortest path methods used in logistics, networking, and GPS route optimization. In real career operations, routes are not always simple or two-way. Some routes are one-way, others are longer or shorter because of terrain, shortcuts, or roundabouts. In career plan routes manually, they often travel unnecessary extra distance, wasting fuel, time, and energy. So, these inefficiencies also increase delivery costs and reduce customer satisfaction. So, this project stimulates a delivery network with 10 locations starting from the main warehouse, which is A. Since road distances are directional and unequal, the network is represented using a directed weighted graph. By applying Dijkstra's algorithm, we can identify the shortest and most cost-effective path, making route planning more accurate and data-driven. So, this is proven that shortest path method used in various platforms. So this is the daily problem that I chose, which is couriers that delivers all the parcels face one-way roads and unequal distance between destinations. So manual route planning leads to longer travel, wasted fuel and time, and inefficient routes increase delivery costs and reduce customer satisfaction. So we need optimization to find the shortest and most efficient path. So this shows the directed graphical map explanation that consists of 10 vertices labeled A to J connected by one-way path with different distances in kilometers. So each vertex represents a delivery point and each edge shows the travel direction and distance. So this design uh, shows the real-world road conditions such as shortcuts, hills, and roundabouts. So the A to B is 2.5 kilometer, A to E is 2.5 kilometer, which is the main road, and A to E is 2.5 kilometer, and G to J is 1.8 kilometer. By modeling the system this way, we can clearly visualize and analyze every possible delivery route before choosing the most efficient one. So this is the visual graph, helps identify optimal delivery paths and road connections. So if we use different paths, there will be different totals of kilometers. The main goal for any courier is to minimize distance and travel time. So to achieve that, I apply Dijkstra's algorithm to compute the shortest possible route from point A to point J. So this algorithm works by assigning a tentative distance to each vertex and updating it whenever a shorter route is discovered. So through this process, um, the system always identifies the most optimal path available. So some key benefits of this approach includes efficiency, which saves fuel and travel time, scalability, works even for larger city networks, reliability, avoids duplicated routes, and decision support helps management plan deliveries based on data, not guesswork. Okay, let me briefly explain how I applied the algorithm. So, step 1, initialization. From the starting point A, there are three direct paths. From A to B, 2.5 kilometers, A to E is 2.5 kilometers, and A to G is 2.8. So, the nearest nodes are B and E, both at 2.5 kilometers. Step 2, explore. From B and E, new paths appear. B to C is 1.5 kilometers, total 4 kilometers. E to D, 1.5 kilometers, total 4 kilometers. And E to I is 1.5 kilometers, total 4 kilometers. And then step 3, intermediate paths. Uh, I'll follow the route from D to F, which is A to E to D to F, and the total kilometers is 5.5. If I use the path I to J, which is 1.2 kilometers, so from A to E to I to J, there will be total of 5.2 kilometers. And if I use G to J, which is 1.8 kilometers, the total kilometers is 8 to G, and lastly final destination is J, so the total kilometers is 4.6. After comparing all routes, the shortest path is A and then G to J with a total distance of 4.6 kilometers. So this path avoids unnecessary intersections, follows road direction rules, and minimizes travel distance. Okay, here's why the path from A to J is considered optimal. So it is the shortest distance, which is 4.6 kilometers, and it has the minimal total among all options. Okay, secondly, it is valid directions. The route follows legal one-way roads. Thirdly, it saves fuel and time, which reduces travel costs compared to other routes like A to E to I to J, which is the total is 5.2 kilometers. And fourthly, the algorithmic accuracy, Dijkstra ensures and really guarantees the shortest route in graphs with positive weights. Next is the scalability. The same approach can be used for larger courier or urban delivery systems, not only the specific place that I chose. And next is realistic modeling. So it reflects real life asymmetric road distances and restrictions. In short, this route is both mathematically optimal and logistically realistic, and it really helps to reduce total delivery cost. Okay, to conclude, this project successfully shows how graph theory and Dijkstra algorithm can be used to optimize real-life courier delivery routes. By modeling the network as a directed weighted graph with 10 nodes, we capture real constraints such as one-way traffic and uneven distances. The shortest path, A to checkpoint G, and lastly to J, is 4.6 kilometers, demonstrates a cost-effective, fuel-efficient, and accurate route plan. So, this approach can be extended to larger logistics systems or city-scale planning, supporting Malaysia's move towards smart and sustainable urban mobility. Thank you. So here are the main references that supported this study.